Hi, this is Mrs. Travis, and I want to walk you guys through finding the perimeter of a composite figure involving a triangle and a semicircle. First, just really quickly, just to review, composite figures are figures that are made out of more than one basic shape. Okay, we have two basic shapes here. We have the triangle and the semicircle. So the perimeter, first, let's talk about what that is, just as a nice review reminder. The perimeter of any figure is going to be the length of its outermost edge. Okay, so it's the highlighted length there. Okay, so let me erase that. So that's what we're trying to find out. So we have the lengths here. So we have this length. So we know that this length here is 15. So this length right here is 15. And then we know that this next length that I'm going to highlight in pink is 12. We do not know what the length I'm going to highlight in green is. So we need to find that out. And the way to find out the length of the green curve is to use the circumference formula. Remembering the circumference is the perimeter of a circle. We don't have a circle, but we do have a half circle. So we can use the circumference formula to find that half circle perimeter. So the circumference of a circle, there are two formulas. We have the circumference of a circle can be found by using the diameter, I'll write in blue, times pi, and then pi I'll write in red. Another formula that we can use to find the circumference is circumference C equals 2 times pi times r, and r represents the radius. So the easiest way to know which one you're going to use is to figure out which information is given. Are you given the length of the diameter, or are you given the length of the radius? And to be honest with you, you can change the length of the radius into the length of the diameter, or change the length of the diameter into the length of the radius if you'd like to. You can easily do that. But I just kind of pick by determining which dimension they give me. So in this image here, and I'll show you with red, they gave me the length here, this little length here. This length, because I know that this is a semicircle, represents the length of the radius. The radius is going to be the length halfway through a circle. A semicircle is half, so this line going completely through the center of it tells us that this is the radius. And so I'll write R right there. That's the radius. They tell us that its length is 6. So the formula that I'm going to use is the formula that has the radius. So I'm going to erase the diameter formula. I'm not going to use that. And then I'm going to erase my little r, and I'm going to put the dimension they give us for radius in its place. And the radius that they give us is 6. So I'm going to use my parentheses. Whenever you're using substitution, you put your numbers in with parentheses, and then you figure out what's going on. The next thing I need to substitute in my formula is the pi. So I'll erase pi. I'm going to put its number in its place. And pi is always going to be represented in this chapter as 3.14. Oh, I don't have enough room. So let me erase some stuff here, and then I'll redo it really quickly. I underestimated the amount of space I needed. So I'll space it out. C equals, and then we have our 2. All right, and then now we're putting in pi. Pi is the 3.14. Okay, so we have all the numbers in the formula. Our formula has been converted from variables and symbols to all numbers. So we know parentheses mean to multiply. So we're going to multiply all three of these numbers together. And I'll just use my calculator really quickly to figure that out this time instead of manually doing it to save time. I have 2 times 3.14 times 6. Okay, so the answer, it's not the final answer, but the answer, once I'm using multiplied all those numbers together, is going to be 37 and 68/100ths. Now, this would be the distance around a full circle with a radius of 6. We do not have a full circle. We have a semicircle. So because we have a semicircle, we have to take this number and divide it by 2. And that, again, is because we have a semicircle, half of a full circle. So we only have half of that circumference or a perimeter. So we're going to divide that number by 2, and we end up with the length of 18 and 84/100ths. So that tells us that this distance here is going to be 18.84, okay? And the units are meters for this problem. All right, so that's the distance around there. So the last thing we have to do is take our 3 dimensions and add them all together to get the total perimeter of this composite figure. So the perimeter is going to equal, let me write perimeter here, the 18 and 84/100ths plus the 12 plus the 15. So that is going to be, using my calculator here, if I punch the numbers in correctly, we should get 45 and 84/100ths meters. So this would be the answer to this problem. So one of the things I want to reiterate is when you're determining what formula to use for finding the half circumferences, you want to look to see if they give you the diameter of a semicircle or if they're giving you the radius of the semicircle. So recognizing the diameter or radius of the semicircles and what those dimensions are is really 50% of what you got to do. Once you've done that, the other 50% is just using the correct circumference formula and dividing it by 2. Okay, I hope this made sense. If you have any questions, please don't hesitate to email me.